For that lovely introduction. I work at Marvel App, not that one. Marvel App, which is a collaborative design platform. As Simona mentioned, I'm the co-creator of AI.js.rocks, which is a collection of AI-powered JavaScript apps and demos. And I also run AI JavaScript London, which is a meetup for JavaScript developers with talks and workshops on all things AI and machine learning. So I'm mostly a front-end developer. I use React day-to-day, but recently I've been delving into the realms of data science, AI, and machine learning. So why would a JavaScript developer care about machine learning? And when I go to machine learning meetups and other events, people say to me, but machine learning is for Python developers, or R, maybe Java or Scala. They say JavaScript is for building web apps. You build forms, you make API requests. You shouldn't be concerning yourselves with hardcore algorithms and big data sets. And okay, perhaps JavaScript isn't the first language which springs to mind when you say machine learning, for reasons which I'll go into shortly. But that does seem to be changing, especially with the announcement of Tensorflow JS, which was unveiled last year. So for the first time, a major machine learning library, i.e. Tensorflow, has offered a fully supported, entirely JavaScript-based version. So this is big news for JavaScript developers. Tensorflow JS works in the browser. And do you know which language works in the browser? You guessed it. So before I talk more about JavaScript and machine learning, I'm going to give a brief high-level overview into some areas of machine learning. As somebody from a web development background who has been learning about data science, AI, and machine learning, I wanted to clarify some of the concepts and definitions which I personally found a little confusing along the way. So let's talk about the differences between data science, machine learning, and AI. So data science involves solving complex problems using data. So this can cover things such as analytics, mining, visualization, statistics, and more. Artificial intelligence is the simulation of a human brain function by machines. So this would cover perception, so vision, touch, hearing, actions and movements, so robotics and the ability to move and manipulate objects. Natural language processing, so speech and text. Planning, for example, playing chess and predicting moves, and reasoning and knowledge, so for example, IBM Watson playing the quiz show Jeopardy. So machine learning involves looking at data and finding insights without specifically having to be told what to look for. So this is different to traditional computer algorithms, as it specifically involves learning. So a subfield of both data science and AI is machine learning. Machine learning itself has three main subfields: supervised, unsupervised, and reinforcement learning. And whilst there are many machine learning algorithms which solve specific problems, the main thing which you should focus on when starting your journey into machine learning is artificial neural networks. Now, I've no doubt that many of you have already heard of artificial neural networks. Perhaps you think they sound interesting, you'd like to know more, or maybe you've even already been reading or learning about them already. I can tell you that artificial neural networks are the most exciting thing happening within the field of machine learning right now. So they're incredibly powerful, and they're even moving into other AI subdomains such as natural language processing and robotics, where previously applied algorithms are being replaced with neural networks to great success. So they've actually been theorized since the 1950s, but it's only recently that we've had enough processing power to actually get them to work. So artificial neural networks are inspired by biological networks, so they're based in the brain and how we think. This is what a real biological neuron looks like. The dendrites are the inputs, the axons are the outputs. When enough dendrites fire, then the axons will fire outwards. Your brain has about 100 billion of these neurons, all connected together in a neural network. So an artificial neuron works much the same. It's essentially an algorithm which receives a set of values, and if these values are high enough, it will activate. So in this case, we have two inputs, 0.3, 0.7, and then the next step is to assign weights to these inputs, which represents how important they are. Usually, especially using a library such as Tensorflow, it would initialize all of these weights randomly, and then they would be automatically adjusted to reflect the importance of the inputs based on the findings of the neural network. You'd also add a bias to inputs with 0, and then we have something called an activation function, which is what's going to make the neuron fire or activate if the incoming inputs and weights reach a certain threshold. So the inputs get multiplied by their weights and then added together and passed into the activation function. For now, our activation function is going to be really simple. If the sum of the inputs times weights is positive, the neuron will activate. If it's negative, it will not. So in this case, the neuron receives a positive value of 2.7 and it will activate. The activation function returns a 1 and not a 0. So this activation function is called a threshold function and it looks like this. The problem with this activation function, however, is that you only have to be a tiny amount either side of the point in the middle to yield completely different results. So there's many activation functions. Other common ones are sigmoid and ReLU, both of which allow smaller changes to be taken into account when deciding whether a neuron activates or not. So if you connect many neurons together in rows and layers, you make a neural network. Here we have 4 layers. The purple layer is the input layer. There's 2 hidden layers, and the blue and the green, and the output layer is the red one. So your input layers represent your real data. If you were predicting house prices, for example, then these might represent number of rooms, the age of the house, square footage, and so on. The red layer on the right is your output layer. It's just the thing you're trying to predict. So in this case, we only have one output, the price of the house. We also have these 2 hidden layers, which receive inputs and pass outputs. These 2 hidden layers are called dense layers, as they're fully connected. So again, we would assign weights to each input. Then the data flows from the input layer, hits the neurons in the next layer, and then if it's activated based on the weights, it will send the outputs forward to connected neurons in the next layer. When training a neural network, and you need to train a neural network for it to be useful, in most cases you would already know the expected result, which is known as supervised learning. You can then use something called a loss function to calculate how far off the model's output is from the correct output. So in this case, for example, the model predicted 3, but we were expecting 8. And then we would use something called an optimizer algorithm, which is the thing doing the actual training. Its job is to go back and update the weights and biases in order to get the outputs closer to the expected results. So you would repeat this a bunch of times with many sets of inputs and expected outputs, and eventually you get a trained model which can receive inputs and give accurate predictions. So why all the hype with neural networks? Well, they're actually quite general. You can learn the basis and then apply the same techniques and tools to a wide range of different problems with only a little tweaking and not much domain-specific knowledge required. Neural networks work best with labeled data, and more available data is becoming available every day. This means that developers, researchers, and businesses can make use of this ever-increasing computing power and available data. And they can use neural networks to find patterns which they never would have been able to by just searching and analysing the data themselves. So how do we actually carry out machine learning? I previously demonstrated how an artificial neural network works, but what about the technology we, as developers, can use to implement this? More specifically, what can we as JavaScript developers use to implement this? Well, until recently, not so much. Compared to Python, the go-to language for scientific computing and machine learning, JavaScript is barely a fraction of the tools and resources available. Setting up models involves configuring how you pass a set of inputs through a set of functions and algorithms. So if that's all there is to it, then why hasn't JavaScript been a contender with other languages when it comes to machine learning? JavaScript has matured a lot over the last 5 years, and it has a huge community around it. It's also everywhere. It's in the browser, in the cloud, it's building front ends, back ends, games, mobile apps, desktop apps. It was crowned the most popular language of 2018, 2017, 2016, 2015, and 2014, as per the Stack Overflow Developer Survey. However, despite JavaScript's popularity, the widespread adoption and the continuous stream of new tools, packages, and frameworks, there's been this great big closed-off domain to JavaScript developers, that of AI and machine learning. So why have all these things been so out of reach for JavaScript developers? JavaScript is a general purpose language. You can, and people do, build anything and everything out of it. Python was also designed to be a high-level general purpose language. But the main reason that Python has been crowned king of machine learning is because of the awesome community around it. Python was designed right from the start to be syntactically elegant and easy to learn, so academics and researchers picked it up. It was easy for them to test ideas and allowed them to focus on research and findings. JavaScript has only recently become syntactically elegant with things such as generators and async await being added. There have, of course, been some interesting open source JavaScript projects for scientific computing and machine learning. Brain.js, Synaptic.js, PropelML, GPU.js, and so on. But generally speaking, JavaScript just doesn't compare when it comes to the number of tools and packages for machine learning. But it doesn't have to be that way. Especially now we have Tensorflow JS. So Tensorflow JS was announced the 30th of March last year, and version 1.0 was unveiled at the TensorFlow Dev Summit a few weeks ago. So it's still fairly new, but it's arguably the most exciting thing to happen with JavaScript and machine learning so far. So before I show you more about TensorFlow JS, let's look at what TensorFlow is. TensorFlow is an incredibly powerful machine learning and deep learning library. It allows data flow programming across a wide range of tasks, and as well as being a symbolic maths library, it's also used for machine learning applications such as neural networks. TensorFlow was developed by Google Brain for internal use, and it was open sourced in November 2015. Since then, it has quickly become one of the most popular machine learning frameworks on the scene. TensorFlow's GitHub repo has nearly 4 times the number of stars of scikit-learn, which is the next most starred machine learning project. TensorFlow allows developers to create large-scale neural networks with many layers, and it can process and create models for things such as voice and sound recognition, language detection, and a whole lot more. NASA used TensorFlow to find new planets orbiting stars. And more recently, students have been using TensorFlow to map craters to try and figure out where matter has existed in various places across different times to try and understand the very origins of our solar system. It's even being used to prevent illegal deforestation in the Amazon. So solar-powered, upcycled phones are hidden high up in trees, and they're trained using TensorFlow to recognize the sound of chainsaws or logging trucks and alert the rangers who police the forest. So now we have TensorFlow JS. So this is TensorFlow completely rewritten in JavaScript. And despite the shared methods and almost identical API, you don't need TensorFlow or anything else installed to use TensorFlow JS. So let's look at how TensorFlow JS came about. Well, firstly, because of the popularity of the TensorFlow Playground. This is an in-browser interactive visualization of a neural network. So you can see how adding layers and neurons work and how changing these yield different results. So, for example, here, we're trying to find the difference between the yellow and blue dots. And at first it doesn't do particularly well, and then it adds more neurons, another layer, and then it has no problem finding the line of separation. So the code used to make this website is all open source. There's a repo on the TensorFlow GitHub page, and this was turned into a library called deeplearn.js, which has now become TensorFlow JS. So TensorFlow JS is just the next iteration of that work. DeepLearn was only released in August 2017, and in the short time before joining the TensorFlow family, they released a bunch of demos, such as style transfer, where you can apply the style of a famous artist's work to any photo. This here is applying the style of Francis Picabia to a photo of Scarlett Johansson. DeepLearn JS also created Teachable Machine, where you can train a neural network to use your computer's camera with things such as like a hand or head movement to trigger the loading of set sounds or images. So you capture frames by holding down one of the colored train buttons whilst doing the action. And then after the training, the neural network will trigger one of the outputs on the right when you repeat this action. So this demo is really cool, actually, and it's on the Tensorflow JS website if you want to have a play. So Tensorflow JS is able to train models in the browser, and it uses WebGL to do that. This is an API used by browsers to access your graphics card or your GPU. So running in the browser means no setting up drivers or installs, and it works across all devices. TensorFlow JS also works server-side. They released Node.js bindings for TensorFlow, which means the same JavaScript code can work on both the browser and the server. So what can you actually do with TensorFlow JS? Well, 3 things. You can create and train models in the browser or server-side. You can run pre-trained models in the browser in what's called inference mode. And you can retrain an existing model, which is called transfer learning. So there are many AI and machine learning JavaScript apps and demos popping up now, many of which are featured on AIJS.rocks. So do check it out if you can and have a play around. Many of them let you interact by drawing, uploading an image, or by accessing your camera for image detection, or even for capturing your movements as a controller. And there are also games, such as this one. So this is a Pac-Man game where you can use your head movements as the game controller. So this is my friend Asim, who was very keen to be in this demo because he had just bought this new hat, and he was very proud of this new hat. So Asim is the other creator of AIJS.rocks, and here he is capturing images using his webcam, ready to play the Pac-Man game. So the app loads a model which has already been trained, but it requires the user to do this additional training session so the model can update itself based on the user's specific movements. So here you can see the model captures extra frames for up, down, left, and right, and then it gets trained with these right inside the browser. And then you can play the game using movements as controllers like this. Okay, so another fun demo I want to show you is Move Mirror, which was made by the smart people at the Google Creative Lab, which lets you explore pictures in a fun way. So you turn on your webcam and move around, and the computer will pull up pictures of poses which match yours in real time from a database of more than 80,000 images. And of course, here's Asim again, trying it out. So this game uses a pre-trained model called PoseNet, which detects positions of 17 points on the body, such as eyes, ears, wrists, and knees. It runs entirely on the browser, and it can be used with any webcam. So I also want to show you SketchRNN, which is a generative recurrent neural network capable of producing sketches of common objects. As you can see here, I started this drawing by adding one line, and the model will then continue my drawing. So I've selected a bird here, but there's many different subjects to choose from. So this was made by David Ha with the goal of training models to draw and generalize abstract concepts in a similar way to humans. It was trained on a data set of handwritten hand-drawn sketches, and it has the potential to help artists with their work or help people learn to draw. So this is a JavaScript implementation of Magenta's Sketch RNN model. So Magenta is a research project exploring the role of machine learning in the process of creating art and music. Primarily, this involves developing new deep learning and reinforcement learning algorithms for generating songs, images, drawings, and other materials. And there is Magenta JS, which uses Tensorflow JS to run the Magenta models. So if you're interested in the creative side of machine learning and JavaScript, then you should definitely check it out. So it's super easy to add TensorFlow JS to your project. You can use npm or yarn, or you can link to the CDN and a script tag right inside your browser in your HTML file, and then you have access to the global TF object where you can carry out various methods and operations. For training models, the library consists of two different packages, the core API and the layers API. A tensor is the central unit of data in TensorFlow JS, and it's basically a multi-dimensional array of numbers. So you can create a tensor by doing tf.tensor and passing it an array of values and a shape of rows and columns, or you can infer the shape with nested arrays. So then you can perform maths operations on these, for example, a.square, and of course you can use chaining, as with any other JavaScript. The flexible low-level core API is syntactically very similar to the TensorFlow Python library, and it involves storing data using tensors, then applying maths operations on them to represent the work the model does. So this is an example of doing polynomial regression, which is like linear regression but a curve. And here we are predicting what the y value will be, knowing the value of x, so we can plot it on a graph. So this is not deep learning. Regression is generally referred to as shallow learning. Setting up layers for a neural network with these maths operations is a lot more complicated. So let's look at the layers API. So this higher level Keras-inspired layers API makes it a whole lot easier to build and train models. You can create a neural network with pre-constructed layers, such as in this example. Here we create a dense layer, which means it's fully connected. And we pass it a config object with some data, such as the number of units for the dimensionality of the output space and the activation function. So in this case, we're using ReLU, if you remember what that looks like from our neural network intro. So the activation function is going to tell each neuron in this layer whether to activate or not based on the inputs and input weights. We also need to record how far off the expected output we are using a loss function. Mean squared error is a common and straightforward loss function, so we'll use that. We also need to use an optimizer, and this is going to go back and adjust the weights. So hopefully when the model iterates over and over again, it will get a lower loss rate and the outputs will be closer to the expected ones. You would call model.compile with your loss function and your optimizer, and model.fit with your data. X is your data, Y is the corresponding labels. Because TensorFlow JS uses the GPU to accelerate maths operations, you do have to think a bit about memory management when creating loads of tensors. You'll need to clean them up after your function has run. This sounds scary to JavaScript developers, but don't worry, it's nothing like the hardcore memory management that C developers have to do. You simply wrap your function with tf.tidy, or use dispose, which is similar, but called directly on the tensors or variables. And then your browser won't crash because of a memory leak. So I've talked about how to train a model with TensorFlow JS. Let's see about how to load a pre-trained model straight into your browser. With a pre-trained model, we simply call tf.loadModel and pass a URL. So this is a URL to a pre-trained model called MobileNet, which is an open source convolutional neural network architecture relating to image recognition. There are many types of neural network, but whenever you hear convolutional neural network, most of the time think image detection. MobileNet was trained on a large subset of image database, a huge image database called ImageNet. and it was optimized to perform image detection on mobile devices and embedded applications. So there's more information about MobileNet on TensorFlow GitHub under examples, and it's a really interesting one to have a play around with. So you don't need any prior machine learning knowledge. You can simply load this model, then you would pass it an HTML image, video, or canvas tag, and it will return an array of the most likely predictions and the percentage of confidence. So as well as training a model and loading a pre-trained model, the third thing you can do with TensorFlow JS is transfer learning. This is where you train the tail end of an existing model. So using the MobileNet example once again, you would load the model and set it to a variable. Then you would call getLayer on this and pass it the name of the layer. Once you have this last layer, you can create your own model, just like we did in the previous examples, and train it with your own data. So the Pac-Man demo was using MobileNet and retraining it with the user's extra images captured during the training. So there you have it, 3 ways you can use TensorFlow JS: training a model, loading a pre-trained model, and retraining an existing model. So if you're wondering about performance, this is a benchmark for running a MobileNet model in inference mode, comparing the JavaScript and Python versions of TensorFlow. So if you remember, inference mode means running a model which has already been trained. So the standard Python TensorFlow, when used with a powerful CUDA graphics card, gets less than 3 milliseconds. And just using the CPU of something like a MacBook Pro would take about 60 milliseconds. Compared to TensorFlow JS, running with the fancy graphics card, it results in just under 11 milliseconds. And for running on the integrated graphics card of a laptop, it's around 100 milliseconds. But these are milliseconds. So it's important to realize that even 100 milliseconds is not that bad, and it's only going to improve as both the technology and the web improve. And you can already build some amazing applications with this already. So a whole world of potential applications of JavaScript and machine learning has opened up with the announcement of TensorFlow JS. And I also want to mention the availability of machine learning APIs. Google, Microsoft, AWS, IBM, and many other companies now provide a range of APIs for things such as natural language processing, recommendations, forecasting, image and video analysis, and they're all pretty easy to use when it comes to building machine learning apps. Whilst much of machine learning is maths, stats, probability, functions, and algorithms, machine learning is not done in isolation. It is often applied in some kind of application context, such as speech or text processing or computer vision, with this data being used as the input to the machine learning models. JavaScript is the de facto language to build apps and interfaces which can consume user interaction data. So mouse events, text and voice inputs, video inputs by the camera, and then potentially GPS, gyroscope, and more depending on your device. With TensorFlow JS or other APIs, data generated from these user events can be processed and sent to a model server-side, or it can just stay in the browser. So as JavaScript developers, we are not necessarily trying to play catch-up with Python when it comes to AI and machine learning. At least when it comes to building machine learning applications, we have our own place as masters of the browser and user interaction data. If you want to become really good at machine learning, then yes, you still have to learn the maths, linear algebra, formula, and so on. But if you want to see what all the fuss is about, have a play, maybe build something really cool really quickly, you can just load an existing model or use a machine learning API and come up with new and creative ways to send data to it via an interface or app. And then if you want to go a bit deeper, you could try retraining an existing model with new data. As it's so easy to use in the browser, you can just open a new code pen and add the CDN or import the package and start playing with it right away. So I hope that this has encouraged you to pursue trying to build, or at least try out a couple of projects using machine learning and JavaScript. I highly recommend going to the official website, js.tensorflow.org, and working your way through some of the tutorials on there, as well as going through the TensorFlow GitHub, especially on the TFJS examples repo, as there are many examples for you to try out, including MobileNet. There are, of course, a bunch of interactive demos you can have a play with on aijs.rocks. And I also want to mention ML5JS, which is a wrapper around Tensorflow JS, which makes it even easier to load and access pre-trained models in your browser. And if you're looking for video tutorials, do check out Daniel Schiffman from the Coding Chain. He's got some excellent series on YouTube where he trains a model using Tensorflow JS, as well as someone training a neural network using vanilla JavaScript. And as I mentioned before, there's several APIs, such as Google's AutoML and Microsoft's Cognitive Services, which you can find tutorials for online. So the future of machine learning and JavaScript. Well, it's certainly bright. The examples I've shown are mostly fun or creative rather than solving real-world or enterprise problems, but I think that we'll see more examples of solving these problems over the coming months. There's a lot of potential to build accessible apps using head movements or voice as controllers, for example, and also potential to build privacy-friendly apps. So running models in the browser means that the user data doesn't have to be sent server-side anywhere. This is great for things such as health apps, where data privacy is really important. There's no doubt that as more and more JavaScript developers get involved in machine learning, further tools will evolve as the community grows. And I'm hoping that this community will include you. Thank you for listening.